solve, I guess, what you would call an exponential factorial equation. Notice this says x minus 1 factorial, quantity squared. Now, my x, remember the natural numbers, folks, just means the very same thing as x equals to just the counting numbers. X equals to 1, 2, 3, and we'll go ahead and put the ellipse to indicate ad infinitum or and so on. Okay. Now, the very first, all I did is recopy the statement right here. And here, this going from this line to this line is just the definition of what it means to square something. We split it apart into two separate factors, x minus 1 factorial times x minus 1 factorial. Okay. And now, notice this piece right here. Let me see if I can get this circled. This piece right here, from the definition of factorial, just becomes this circled piece down here. Okay, the same thing. Notice we changed it to x plus 1 because x plus 1 is the last factor in the circled expression. That's just definition of factorial. Now also notice that this piece right here, 132, that's the only part that's a little deceptive, but 132 is the same as 11 times 12, right? So we can write 132 as 11 dot 12, right? But notice what happens there. When we combine 11 dot 12, 11 times 12 with 10 factorial, we get 10, 1, 2, 3, 4, 5, 6, 7, 8, 10 times 11 times 12, right, which is 12 factorial. So this entire expression right here would become x minus 1. I'm just recopying here. X minus 1 factorial. Okay, times x plus 1 factorial. Okay, and then just again from the definition of factorial, this would become 12 factorial. And I'm using a dot here to connote multiplication. Dot, multiply, 14 factorial. And now we have it in a very so-called tractable, or I guess simple form. Okay, we have two factorial expressions here, and by inspection, x has to be 13. If x is 13, this would be 12. If x is 13, this would be 14. And so by inspection, literally, there's no need to go any further with this. You would get the final solution is x equals 13, which is certainly a natural number. And you're not surprised to hear that when you're dealing with factorials. Okay, circle that, folks. Call it good.